Hello everyone, thank you for signing in and watching my live stream. Welcome to SAT, ACT Prep. I'm Mr. Matt and this is Dr. Tot. You want to go key Dr. Tot? Good boy. And today we're going to wrap up the mixed review of lessons 1 through 3. So in lesson 1 we talked about the rules of exponents. In lesson 2 we talked about solving using substitution or solving conceptually. This mostly occurred with multi-statement SAT questions. And then in lesson 3, we talked about the LCM, or the least common multiple, and the GCF, the greatest common factor, and how that plays into different problems, particularly with rates. So let me go ahead and share my screen with you. I want to just kind of jump right into some review questions. And so I have 11 original questions written here for today's session. If there are any recommendations, I'm more than willing to entertain them. So you can just send them in the comments section below. Otherwise, let's take a look at these problems. I'm going to give you 3 minutes. Questions 1 and 2 are based on the following definitions. For all positive integers h, let $H$ represent the number of positive multiples of h less than 25. And number 1 is asking which of the following statements is or are true. $5 plus $4 is equal to 10. Statement 2 says $5 times $3 is equal to 11. And statement 3 says $3 plus $4 is equal to 12. So remember that these are symbolism questions. You have to focus in on the definition in order to evaluate what each of these values are. $5 no longer $5, for example, no longer represents the value 5. It represents whatever they tell you in the definition of how to evaluate that symbol. So I'll give you 3 minutes and then I'll give you the solution. And as always, I'll keep track of the time in the upper right-hand corner here, and I'll update it per minute. Okay, so obviously dollar sign, some number dollar sign is not a real mathematical symbol or operation. But that's okay. They define the symbol here as to represent the number of positive multiples of h less than 25. So this is saying whenever they wrap dollar signs around some number that they're calling h, it no longer represents the value of that number. It represents instead the number of positive multiples of that number, h, less than 25. So if we were to, well, first recognize that we have repeating values here. You have $5, $4, and then $3. So let's systematically list these out and evaluate them so we don't have to repeat the process over and over again. If I list out the multiples of 5, we'd have 5, 10, 15, 20, 25. Now they say that they have to be less than 25, so we can't actually count 25 itself. Therefore, $5 represents the real value of 4. If we were to evaluate $4, counting by 4s, we'd have 4, 8, 12, 16, 20, 24, 28. Notice that 28 is larger than 25. It's not less than 25, so we can't count it. So $4 is equal to 1, 2, 3, 4, 5, 6. And then lastly, $3, if we list out the multiples, 3, 6, 9, 12, 15, 18, 21, 24, 27. Again, 27 is not less than 25, so we'd have 1, 2, 3, 4, 5, 6, 7, 8 values, 8 multiples of 3 less than 25. Substituting these values in and checking the statement, statement 1 would say that 4 plus 6 is equal to 10. That is in fact true, so statement 1 is true. Statement 2 is saying 4 times 8 is equal to 11. 4 times 8 is not equal to 11, so statement 2 is not true. Statement 3, $3 is equal to 8 plus $4 is equal to 6 is equal to 12. 8 plus 6 is 14, not 12. So your answer here is going to be statement 1 only. If you have any questions at all, then please let me know. You can drop a comment in the comment section below or a comment in the live chat feed. Moving on to question number 2. This is still pertaining to the same definition. So I'll give you 3 minutes and then I'll give you the solution. Okay, so looking at this problem, they're asking for what is the value of $$$$$$$8, $$$$$$$$, each of the dollar signs in parentheses. So you need to start by evaluating from the inside out. So for example, $8, what does that equal? $8 represents the number of multiples of 8 less than 24. So the multiples of 8 will be 8, 16, 24, excuse me, less than 25, not 24. 24, 32. Notice that 32 is not less than 25, so we can't count it. But the value of $8 is equivalent to 4. So that means wherever we see $8, we can put in 4. So this is going to turn into $$ of 4. And now we can do the same thing. Oh, excuse me. This should not be 4. This should be 3 because we can't count 32. I'm sorry. Catch myself there. So this should be $3. So now we need to evaluate this guy in here. What is $3? Well, we actually evaluated that for question number 1. If you look up here, we know that $3 is equal to 8. So this is going to kind of revolve back and forth. $3 is 8. There are 8 multiples of 3 less than 25. So for this whole thing right here, we can put in 8. So then we get back again $8, which will revolve again into 3. We've already solved that in the first step right there. So this kind of does a flip-flop back and forth, but the ultimate answer to number 2 was 3. If you have any questions, then please let me know. Otherwise, let's take a look at question number 3. I'll give you 3 minutes. So number 3 asks, if 3/7 times x plus 5/9 times x plus 2/10 times x is equal to 5, then what is the value of x? So as it's written, there's a lot of complex fractions here, and what we can do is we can multiply by the LCM in order to simplify these fractions out a great deal. So what I'm going to do is I'm going to first factorize these values and find the LCM of the denominators, that is. So we have denominators of 7, 9, and 10. 7 is prime, so I can't break it down anymore. 9 turns into factors of 3 times 3, both of which are prime. 10 breaks down into 2 times 5. Remember, when calculating the LCM, we take each factor the most number of times that occurs in any one factorization. So 7 occurs once in 7, 0 times in 9, 0 times in 10. So 1 is the greatest number of times 7 is used in any one factorization, so I'm going to take 1, 7. Moving on to 3. 3 is used 0 times in 7, 2 times in 9, 0 times in 10. So 2 is the most number of times 3 is used in any one factorization, so I'm going to take 2 3s. Moving on to 2. 2 is used 0 times in 7, 0 times in 9, 1 time in 10, so I'm going to take 1 2. And then 5. 5 is used 0 times in 7, 0 times in 9, and 1 time in 10, so I'm going to take 1 5. Excuse me. Multiplying these values together, we get 7 times 3 times 3 times 2 times 5 is going to be 630. So if I take each of these values, if I multiply on both sides by 630, that will reduce this problem greatly, because I'm not going to have all these complex fractions that I will need to have common denominators for, and then add up all the numerators. So let's just get rid of all of these guys. So I'm going to make sure that I apply the 630 to each of the fractions in the parentheses. So this is going to turn into 630 times 3 over 7 x plus, let me make that x larger, plus 630 times 5 over 9 times x plus 630 times 2 over 10 times x is equal to 5 times 630. 630 and 7 will reduce. 630 divided by 7 is 90, so this is going to turn into 90 times 3. Actually, I'm going to use a little dot. So this is going to turn into 90 times 3 times x plus 630 divided by 9 is 70, so this is going to turn into 70 times 5 times x. 630 divided by 10 is 63, so this is going to turn into 63 times 2 times x. Excuse me. And finally, 5 times 630 is going to be 3,150. 90 times 3 is 270, so this is 270x plus 70 times 5 is 350. And 63 times 2 is going to be 126. So you can see by multiplying by the LCM, I turned all those complex fractions into integers. So now we'd have 270 plus 350 plus 126, which is going to be 746x, is equal to 3,150. Dividing by 746, x is equal to 3,150 divided by 746. And you could either reduce that into a simplified fraction or round to about 4.2. If If you have any questions, then please let me know. Otherwise, let's take a look at number 4. I'll give you 3 minutes, and then I'll give you the solution. Okay, so number 4 asks, Betty set 4 timers. They beep every 2, 3, 5, and 16 seconds respectively. If they are turned on at the exact same time, how many times over the next 2 hours will they all beep together? So we need to find the LCM, the least common multiple of the rates of beeping. The LCM of the individual rates of beeping would give us the rate of simultaneous beeping, or the rate at which they all beep together. So I'm going to first factorize all of my rates in order to find the LCM. So I have 2, 3, 5, and 16. So notice that 2, 3, and 5 are all prime. So we just circle them. We can't break them down any further. 16 can be broken down into 4 times 4, both of which can be broken down into 2 times 2. So the LCM here, taking each factor the most number of times it occurs in any one factorization. 2 occurs a most number of times of 4 times, so I need 4 2's. 3 occurs a most number of times of once, so I take 1 3. And 5 takes a most number of times, occurs a most number of times of 1 time, so I take 1 5. So if we calculate this, this is going to be 2 times 2 times 2 times 2, which in other words is just 16, times 3 times 5, which is going to be 240. So this means that every 240 seconds, and only every 240 seconds, will all 4 timers beep together. Now we also need to know how many seconds are in 2 hours, because they ask us ultimately how many times over the next 2 hours will they all beep together. So I'm going to take 2 hours, and it's my given value, so I'm going to write it as a fraction by putting it over 1. And I'm going to multiply by some conversion factor that in itself, conceptually, is equal to 1. It's just going to be in terms of different units. I have hours in the numerator, so I'm going to put hours in the denominator because I want to cancel hours out, and I want to go to the next smallest denomination, which is minutes. There are 60 minutes in 1 hour, so notice that 60 minutes is the same thing as 1 hour. Therefore, 60 minutes divided by 1 hour technically is something divided by itself, which is 1. 1 times anything is that same something. That's the identity property of multiplication. 1 times anything is that same something. So I'm not changing the value here, I'm just manipulating the units, because if I multiply, now hours will cancel with hours, and I'd have an answer in terms of minutes. But I don't want minutes, I want seconds, so I'm going to go one more time. I have minutes in the numerator, so I'm going to put 1 minute in the denominator, and I'm going to multiply in the numerator by 60 seconds, because there are 60 seconds in 1 minute. Now when I multiply through, minutes will cancel with minutes, and I'll have an answer in terms of seconds. So multiplying completely, I'm going to have 2 times 60 times 60 seconds divided by 1 times 1 times 1, which of course we know is just 1, which has no effect. So 60 times 60 times 2 is going to be 7,200 seconds in 2 hours. So if I take 7,200 seconds and I divide it by the simultaneous rate of beeping, or the rate at which they all beep together, which is every 240 seconds, I'll get 30. So over the next 2 hours, these 4 timers will beep together an exactly 30 times. If you have any questions, as always, please just let me know. Otherwise, question number 5 asks, what number less than 100 has a remainder of 2 when divided by 4, 6, and 18? I'll give you 3 minutes, and then I'll give you the solution. Okay, so if we're looking for a number that has a remainder of 2 when divided by 4, 6, and 18, the first step is to find a number that goes exactly, or excuse me, is exactly divisible by 4, 6, and 18, or in other words, has a remainder of 0 when divided by 4, 6, and 18. Because once you have that value, you can merely add 2 to it, and that would be a value that would have a remainder of 2 when divided by all numbers 4, 6, and 18. So let's find the LCM of 4, 6, and 18. So I'm going to factorize these values. We have 4, 6, and 18. 4 breaks down into 2 times 2. 6 breaks down into 2 times 3. 18 breaks down into 3 times 6. And 6 breaks down into 2 times 3. So taking each factor, the most number of times it occurs in any one factorization, 2 occurs the most number of times 2 times in 4, so I'm going to take 2 2's. 3 occurs a most number of times of 2 times in 18, so I'm going to take 2 3's. 2 times 2 is 4, 4 times 3 is 12, 12 times 3 is 36. So 36 is a number that is exactly divisible by 4, 6, and 18. Therefore, if we merely add 2, 38 is a number less than 100 that has a remainder of 2 when divided by 4, 6, and 18. Now I want to point out here that because the only restriction is that it has to be less than 100, any multiple of the LCM also would work. So if we took 36 times 2, 36 times 2 is 72. If you added 2 to that, 74 is also would also be considered a correct answer here. So this problem actually ends up having 2 possible solutions. So either 38 or 74, multiples of the LCM less than 100 plus 2 would both be graded as correct. If you have any questions, then please let me know. Otherwise, let's take a look at number 6. 6 asks, what is the quotient of the smallest and largest prime factors of 1,188? Remember that quotient is the answer to a division problem. Remember that division is not commutative, meaning that order matters. So make sure that you get the right order there. You're dividing the right thing by the right, you get the numerator correct and the denominator correct. Otherwise, your fraction will be opposite, and that'll be a totally different number, which will be wrong. So I'll give you 3 minutes, and then I'll give you the solution. Okay, so if we're trying to find the quotient of the smallest and largest prime factors of 1188, we're going to have to factorize 1188. So that's a pretty large number. We know that it's even, so we definitely know that it's divisible by 2. But remember your other divisibility rules. If the sum of the digits of the number itself, for example, 1 plus 1 plus 8 plus 8, that's 18. If the sum of the digits of the number itself is divisible by 3 or 9, the number is also divisible by 3 or 9. So 1 plus 1 plus 8 plus 8 is 18. 18 is divisible by 9. So if I take 1188 and divide it by 9, I get 132. Notice that 1 plus 3 plus 2 is 6. 6 is divisible by 3, so I know that this number is also divisible by 3. And that breaks down into 3 times 44. 3 is prime. 9 breaks down into 3 times 3. And 44 breaks down into 4 times 11. And 4 breaks down into 2 times 2. So the smallest prime factor of 1188 is going to be 2. The largest prime factor of 1188 is 11. So the quotient of the smallest and the largest prime factor, respectively, you have to make sure that the smallest one is the numerator and it's being divided by the larger one. So the answer here is going to be 2/11. If you have any questions, then please let me know. Otherwise, let's take a look at question number 7. Question number 7 asks, if 11 times a over 12 plus 9 times a over 10 plus 3 times a over 4 is equal to 10, then what is the value of a? So I'll give you 3 minutes and then I'll give you the solution. Okay, so we have these complex denominators that we want to get rid of. Let's go ahead and find the LCM, because if we find the LCM, the least common multiple of 12, 10, and 4, and multiply both equations on both sides of the equations by that value, it will eliminate all the denominators and turn these fractions into integer values. So we have denominators of 12, 10, and 4. 12 will break down into 3 times 4. 3 is prime. 4 is going to break down into 2 times 2. 10 will break down into 2 times 5. And 4 will break down into 2 times 2. Taking each factor, the most number of times that occurs in any one factorization. 3 occurs 1 time in 12, 0 times in 10, 0 times in 4, so I'm going to take 1, 3. 2 occurs 2 times in 12, 1 time in 10, 2 times in 4, so I'm going to take 2 2's. 5 occurs 0 times in 12, 1 time in 10, 0 times in 4, so I'm going to take 1 5. 3 times 2 times 2 times 5 is going to be equal to 60. And that's a good example of how the LCM is actually not always the product of all the values. So 12 times 10 times 4, that would be 480. That's way larger than 60. So let's go ahead and take this equation and let's multiply on both sides by 60. So 60 has to go to each fraction in the parentheses. So this is going to turn into 60 times 11a over 12 plus 60 times 9a over 10 plus 60 times 3a over 4. And 10 times 60 is going to be 600. 60 divided by 12 is 5. So this is going to turn into 5 times 11a, plus 60 divided by 10 is 6, so this is going to turn into 6 times 9a. 60 divided by 4 is 15, so this is going to turn into 15 times 3a is equal to 600. 5 times 11a is 55a. 6 times 9a is 54a. And 15 times 3a is going to be 45a. And that's all equal to 600. So 55 plus 54 is going to be 109. 109 plus 45 is going to be 134. Excuse me, 154. So 154a is equal to 600. So then dividing by 154 on both sides, a is going to be equal to 600 divided by 154. And if we rounded there, that would be about 3.9. So you could leave that as a simplified fraction, or we could evaluate into a decimal of 3.9. If you have any questions, please let me know. Question number 8 asks, if n raised to the x power squared, quantity raised to the y, I messed that up. If n raised to the x power squared, quantity divided by n raised to the y squared power plus x squared power is equal to 9 raised to the negative 9 power, what is the value of y? So this looks very, very strange because you usually don't have a power to another power going on. Just trust me and follow the rules of exponents and things will simplify greatly. Okay, so I'll give you 3 minutes and then I'll give you the solution. Okay, so if we take this equation and just start working with it using the rules of exponents, let me duplicate it here. Oops. Sorry about that. Let me reconnect my iPad there. Sorry about that. Okay, so I copied this down here. On the left-hand side, we have n to the x squared power divided by n to the y squared plus x squared power. Now this looks very strange, but just go about it in a systematic way, knowing or executing the rules of exponents. We have common bases and we're dividing, so we can keep the base, subtract the exponents. So this is going to turn into n to the x squared minus y squared plus x squared power. And that's still equal to n to the negative 9 power. Now the tricky thing is that you need to make sure that this negative gets applied to both values inside of the parentheses. So this is going to turn into n to the x squared minus y squared minus x squared power. Notice that x squared minus x squared have opposite signs but equal magnitude. So they're going to cancel directly, and we're left with n to the negative y squared power is equal to n to the negative 9th power. So we have common bases on opposite sides of an equal sign, so we can drop the bases and equate the exponents. So negative y squared is equal to negative 9. Dividing by negative 1 on both sides, we're going to find that y squared is equal to positive 9. Then taking the square root, y is equal to plus or minus the square root of 9. Remember, when you take the square root on both sides of an equation, you have to consider the positive and the negative answers. So your answers here are going to be plus or minus 3. So you have two answers. If they were to define y to be greater than 0, then your answer here would only be positive 3. They could have equally have defined y to be negative, and so your answer would only be negative 3. So you always have to evaluate given the context of the question. If you have any questions, please let me know. Otherwise, let's look at number 9. If a is an even integer and b is a negative prime less than negative 2, which of the following statements is or are true? Statement 1 says a plus 3b is odd. Statement 2 says the quantity 4a times the quantity 2b is positive. And statement 3 says a minus b is negative. So I'll give you 3 minutes and then I'll give you the answer. Okay, so we could solve this either using substitution or solving conceptually. If we were to solve it with substitution, we need to pick acceptable values given the domain and characteristics of a and b. They say a is an even integer, so maybe I could say a is equal to positive 2, and b is a negative prime less than negative 2. That's just a really tricky way of saying that it's negative and it's odd. So maybe that because all primes less than negative 2 would be odd, because otherwise they would be multiples of 2 and therefore not prime. So if a was, you could say a is equal to positive 2 and b is equal to negative 3, and you could evaluate here. You also know that a is even and b is odd. So this guy, if we were to evaluate conceptually, we'd have an even plus 3, which is an odd, times an odd. So an odd times an odd is an odd, and an even plus an odd will always give you an odd. So statement 1 is true. Statement 2, now we're not testing even versus odd any longer. We're testing positive versus negative. So a is, it just says that a is an even integer. So we're going to assume let's assume that this is also positive. So a has to be a positive even integer. I apologize if since I didn't mention that. But let's assume a is positive. So what we end up having here is we have a positive times a positive times a positive, but b is negative times a negative. So a positive times a positive, that's going to be a positive, but a positive times a negative will result in a negative, which will ultimately negate the whole thing and turn negative. So 2 is not true, assuming that a is positive. And number 2, we have a minus b is negative. So a would be positive 2 minus negative 3. If b is negative, notice when we do the leave change here, we're going to leave this sign alone, which is implicitly positive. Whoops, excuse me, let me scroll my screen up there. Sorry about that. If we leave the 2 alone, which is implicitly positive, and we change the operation, change the second sign, notice that positive 2 minus a negative 3 is the exact same thing as positive 2 plus a positive 3, which would give us a positive result. So statement 3 is not true, so our only true statement here is statement 1 only. If you have any questions, then please let me know. Otherwise, let's take a look at number 10. So number 10 is an extremely complex exponential form. So I'll do my best to read this to you. First of all, they're asking for the value of this complex rational expression. So we're going to have a numerator and denominator. Around the entire fraction, however, there are brackets raising the entire fraction to the third power. The numerator is the quantity 9 cubed times 27 cubed, whole quantity raised to the second power. That's the numerator, divided by 81 times 9 squared, quantity cubed. That's the denominator. And then the whole thing is inside of brackets raised to the third power. And I'd like you to evaluate and leave your answer in exponential form. I'll give you 3 minutes, and then I'll give you the answer. Okay, so first of all, we need to recognize that none of the bases are common. We can't use any of the rules of exponents until we have common bases, so we need to ask ourselves, is there a number that we can exponentiate or raise to different powers that will get us 9, 27, and 81? Well, there is, in fact. Notice that 3 to the third power is 3. 3 squared is 9. 3 cubed is 27. And 3 to the fourth power is 81. So instead of writing 9, I'm going to write 3 squared. Instead of writing 27, I'm going to write 3 cubed. And instead of writing 81, I'm going to write 3 to the fourth power. So just make sure that you're inserting with parentheses. That's really important. So instead of 9, I'm going to write 3 squared. This is still raised to the third power. Instead of 27, I'm going to write 3 cubed, and that's still raised to the second power. Cubed, still raised to the cubed power. The quantity, the whole thing, is raised to the third power, the whole numerator. The whole thing is raised, keep on writing the wrong numbers. The whole thing is, this is cubed, and then the whole thing is squared. Because this guy right here is cubed, and then this guy right here is the squared value. 27 is 3 cubed. So it looks a little confusing. But that's the numerator. The denominator, instead of 81, I'm going to write 3 to the fourth power. And instead of 9, I'm going to write 3 squared. Now that's still squared because the 9 was squared. And then we have the quantity cubed. And this whole thing is inside of brackets. That is quantity raised to the third power. So we got a lot going on here. But just working inside, now we have a power of a power. So inside the brackets, we're going to have 3 raised to the 2 times 3 power. So this is going to be 3 to the 6th power. 3 to the 3 times 3 power is going to be 3 to the 9th power. This whole thing is still raised to the squared power. Quantity squared, I should say. 3 to the 4th, we didn't have a power of a power there, so that just stays 3 to the 4th. Then we have 3 to the 2 times 2 power. That's also 3 to the 4th. Quantity raised to the third power. And then we have brackets of the whole function, the whole rational expression raised to the third power. Now when we have common bases raised to exponents and we multiply those values, we can add the exponents, keep the base, add the exponents. So the numerator here is going to turn into 3 to the 6 plus 9 power. That's 3 to the 15th, quantity squared. 3 to the 4 times 3 to the 4, that's going to be 3 to the 4 plus 4 power, or in other words, 3 to the 8th. And that's quantity cubed, whole thing cubed outside of brackets. Now again, we have a power of a power. So this is going to turn into 3 to the 15 times 2 power, or in other words, 3 to the 30th power, divided by 3 to the 8 times 3 power, which is 3 to the 24th power. Still, we have these brackets with the quantity cubed outside. Now we have common bases raised to exponents, and we're dividing, so we can keep the base, subtract the exponents. So this is equal to 3 to the 30 minus 24 power. That's going to be 3 to the 6th power. Quantity cubed is going to be 3 to the 18th power as your final answer. If you have any questions at all, please let me know. But otherwise, let's go to question number 11, and this will bring us up to the end of class today. Number 11 asks, if 3 to the... No, it does not ask that. I'm sorry. Number 11 asks, if 36 raised to the a power times 6 to the b power is equal to 216 to the c power quantity divided by 36 to the d power. What is c in terms of a, b, and d? I'll give you 3 minutes and then I'll give you the solution. Okay, so notice that as this problem is written, we don't have common bases. We need common bases in order to use any of the rules of exponents. So can we rewrite some number in terms of different powers to equal 6, 36, and 216? So we can, because 6 to the first power is 6, 6 squared is 36, and 6 cubed is 216. So instead of 36, I'm going to write 6 squared in parentheses. So I'm going to say that 6 squared, quantity raised to the a power, times 6 to the b power, that already has a common base, or already has a base of 6, which is what I want. Instead of writing 216, I'm going to write 6 cubed, quantity raised to the c power, divided by 6 squared, quantity raised to the d power. Also recognize that when they say what is c in terms of a, b, and d, that's just a tricky way of saying get c by itself, make sure a, b, and d are on the other side. That's all that means. So now we have powers of powers, so we can go ahead and simplify here. So this is going to turn into 6 to the 2 times a power, or in other words, 6 to the 2a power times 6 to the b power. is going to be equal to 6 to the 3c power. We have a power of a power, so we can multiply. Quantity divided by 6 to the 2d power. Now when we have common bases and we multiply, we can add the exponents. So this is going to be 2 to the 2a plus b power is equal to 6 to the 3c minus 2d power. When we have common bases and we divide, we can keep the base, subtract the exponents. Now we have common bases on opposite sides of an equal sign, so we can drop the bases and equate the exponents. So 2a plus b is equal to 3c minus 2d. And they're asking for c in terms of everything else. So I'm just going to isolate for c on one side. So I'm going to add the 2d. Negative 2d is subtracting from the 3c. So I'm going to add 2d on both sides. That's going to eliminate on the right-hand side and just add on to the left because they don't have common variables, so we can't combine like terms. So 2a plus b plus 2d is equal to 3c. And so dividing by 3 on both sides, we're going to find c is equal to 2a plus b plus 2d, quantity divided by 3. But just recognize that that's the same exact thing as 2/3 a plus 1/3 b plus 2/3 d. So they could present it in either of those ways, and in fact that's the same thing. They could have also said 2a over 3 plus b over 3 plus 2d over 3. You need to be able to recognize that all three of these forms are exactly equivalent terms. So they could have presented the answer selection in either one of these three ways. But as long as you got one of these three forms, that's absolutely great, and that is the correct answer. So if you have any questions at all on anything that we've done, please let me know in the comment section below or in the live chat feed. I'm here for you guys every day. 3 o'clock to 8:45 is when I broadcast live through the different classes. If you guys found this to be helpful, any of my videos to be helpful, please like and favorite the video and subscribe to my channel. I very much appreciate it. Otherwise, I hope you have a wonderful night. And Dr. Tot, do you want to say goodbye to everybody? Dr. Tot fell asleep, but I think he'll wake up for a cookie. Let's see. Come on, do you want to say goodbye to everybody? You guys say goodbye. That's your job. Come on. You can come up here and say goodbye. Up. Go ahead. You can do a paw. You say bye. Oh, sleepy? You go, yes, okay. Thank you guys very much. I'll see you guys soon.